Okay, so let's quickly run through binary compound nomenclature. So we're going to be naming the compounds that involve only two elements. Now, not only two atoms, but two elements. So binary compounds are what we're focusing on right now, and there are three simple rules you're going to follow. Once again, you're going to see the compound formula. You're going to find those the elements and their location on the periodic table, and then you're going to follow these three simple rules. Again, this is only for binary compounds, so only two elements. Now, in the end, we're going to add what are called polyatomic ions, but there's still going to be one metal, and then one type of metal. There could be 1, 2, 3 of those atoms of that metal, and then they'll be in a salt with a polyatomic ion. We'll get to that in a few moments. But remember, there's just three simple rules. You're going to follow these rules when you're naming binary compounds. So, there's three types you're going to encounter. And that's what you're going to do. First thing you want to do is determine what type you are dealing with. So you're going to see a salt. So that's a metal with a nonmetal. This is the first type. Now remember, there's two basic types of metals. One type of metal we call representative metals, main group metals. We know what their charge is by their location on the periodic table. So if that's the first type, if you have a metal that exhibits only one charge, the proper name is an oxidation state, but we'll say only one charge. So it's a representative group 1, group 2, or group 3 metal, 3A, 1A, 2A, 3A. You find it on the periodic table if it's there, and then it's forming a salt with a nonmetal. That's the first type. Okay, so you're going to identify that. Or it could be a metal that's transition metal. So a metal that exhibits two or more charge states. These are transition metals. They're also going to be in a salt with a nonmetal. So the examples I've written down here: iron, Fe, with 2 chlorines because it is a +2 charge, or Fe with 3 chlorines because it's a +3 charge. Now the example just in 4 was sodium and chloride. Sodium will always have a charge of +1. Iron's one of those transition metals. And that's why you're going to look at the salt, and you're first of all going to figure out, is the metal a representative metal or is it transition metal? And then we name those differently. Okay? So this is the two rules. And then the third type of binary compound, these are just nonmetals with nonmetals, right? I've shown examples, Ni3, CCl4. Those are two elements that come from the right side of the periodic table. And they are molecular compounds. They are not ionic. They share electrons. So we name those differently, but they're still binary. So that's what the first thing you want to do. Which type of binary compound am I looking at? Now we're going to go beyond that. Like I said, polyatomic anions, there's a table 4-2. I think that's the number. 4-2. You've got to just know, you've got to see that, and you've got to know what the charge is on that anion. We're talking about things like NO3-, PO4 3-. And those are just formulae that are given in that table, and I'm going to ask you to memorize that table. That's kind of one of the only things I asked you to memorize this whole semester. And those are just, we think of those just as a single element. Okay? And then we're also going to talk about oxyanions and acids, but don't worry about that for right now. Just we're looking at rules for naming binary compounds. So they're either in one of three types. The metal will be a representative metal and therefore exhibit only one oxidation state, and that forms a compound with a nonmetal. That's the binary salt. And then the other one is a transition metal with a nonmetal. We got to name those differently. And then the third type is a nonmetal with a nonmetal. So that's always what you're looking for. Okay? So when you're naming these binary compounds, you always determine, first, is a metal with a nonmetal, or is a nonmetal with a nonmetal? You just look at it, and you find them on the periodic table. You don't memorize it. You find them on the periodic table. So is it a metal with a nonmetal, or is it a nonmetal with a nonmetal? Most compounds are salts. They are not as interesting as molecular compounds, nonmetals with nonmetals. But we focus on these salts first because they're the simplest to figure out. So once you do that, you look at it and you see it's a metal with a nonmetal, then you've got to determine whether that the metal is a main group metal or a transition metal. So let's deal with that first. We've got a metal with a nonmetal, and the metal that we're using is a representative element. They only have one charge, and you find out what that charge is on that metal by looking at the periodic table. If it's group 1, it has 1+. If it's group 2, it has 2+. If it's a group 3, it has 3+. So in that situation, since we know what those charges are, you don't have to name the charge. We all know what it is. Now those are only the representatives. So metal with a nonmetal, and then you focus, well, this is a representative metal. All the transition metals have more than one charge state, but the representative metals only have one charge state. Now you're always going to, there's always going to be a nonmetal in these binary compounds too. And you know what the charge is on every one of those nonmetals. You know it from this location in the periodic table. So the halogens are always -1. Those group 6A's are always -2. N and P, group 5, 3+. In the rare case where you find carbon in one of these salts, so a metal with a nonmetal. So when carbon is in a formula with a metal, it's going to have a charge associated with it. But these are, you know those. So we don't have to say those in the name either. So we're talking about binary compounds, metal with a nonmetal, and we know the charge on the metal because it's in group 1A, group 2A, or group 3A. See, so you know, we already talked about this. You know what the formula is going to be because you know the charges. So that's how you get the formulas. We talked about that. Now let's name them. Since the charge on each of those is known, the formula is implied, you just use the name of the metal with no changes. So I'm talking about metal with a nonmetal, and the metal is a representative. Group 1A, Group 2A, Group 3A with a nonmetal. So to name it, use the name of the metal with no change. Now to say it's a salt, so we have to say that that nonmetal is not neutral, that it has a charge associated with it. We take the stem of that nonmetal and then add the suffix IDE. So an example would be sodium. Don't have to say the charge because it's group 1A. We know it's a 1+. And then it's chloride. Not chlorine, it's chloride. Ide means it is negatively charged. Another example here I have is magnesium chloride. We don't have to say the charge of magnesium. It's in group 2. You find it on the periodic table. Group 2A, you know it's +2. You know the charge on chlorine is -1, so it's chloride. And you don't have to say the ratio because you know the formula has to be, since magnesium has 2+, chloride is -1, the ratio has to be 1 magnesium to 2 chlorides. These are a metal with a nonmetal when the metal is representative. So here's some examples, right? Rubidium selenide. Now, you don't want to memorize this. You want to go find rubidium on the periodic table. You want to find selenide on the periodic table. You're going to find out it is metal with a nonmetal, and the metal is a representative metal. So you know the charge on rubidium. It's group 1A, so it's going to be 1+. Selenium is a metal. It's down at the bottom. It's group 7. It's not. It's group 6. If you go find it, it's group 6. So it's going to be 6 -8 and have a charge of -2, and therefore the formula is going to have to be Rb2Se to balance those charges. So the name, we don't have to specify the ratio in the name. It's just rubidium selenide. Now the next example, strontium hydride. Hydride, when hydrogen is in a salt with a metal, it takes on a negative charge, and it's a -1. Always a -1. Now when it's in a salt with a negative or a nonmetal, then it's going to be +1. But when we have strontium hydrogen, strontium's a metal, that's going to make the hydrogen a negative charged species, and it's going to have a charge of -1. You find strontium on the periodic table, you see it's in group 2A, it has to have a charge of +2. Hydrogen is a -1 when it's with a metal, so it is a formula of SRH2. We don't specify the ratio in the name because we know the charge on strontium, we know the charge on hydrogen, and they can only exist in a ratio where the charges neutralize or cancel each other. This last example, radium oxide. Don't know. You have to find them on the periodic table. You find radium and you find oxygen. Radium is group 1A, so it's going to be a +1. It isn't though. Radium, if you go, I've got this, I'm sorry, I've made some errors here, right? Radium, if we find it on the periodic table, which I should go back and do, right? Radium is a +2. It's in group 2A. Group 2A, there it is, bottom left-hand corner, it's 2. Now we're hitting here. So it's a +2. Oxygen is a group 6. Again, for whatever reason, I have 7 down there. It's group 6, so it's going to be oxygen is 6 - 8 - 2, and it's going to be 1-to-1 ratio to cancel those charges. But again, we just call it radium oxide, and don't say the charge in the name because they're on the periodic table.